Okay, so in this unit, okay, we are going to cover climate, okay, mostly what climate is and what factors can affect climate. Okay, we'll talk about energy, okay, different types of energy on Earth, different ways to transfer energy around the Earth, okay, and we'll look at specific heat capacity, latent heat, the heating curve of water, and a little bit of stuff about ecosystem structure, okay, and that's really about it. It's supposed to be a unit that ties everything together in a global system. So some stuff about chemistry, some stuff about biology, some stuff about thermodynamics from physics, okay, all into one thing. I don't know if it really does that, but okay, we're going to go through it anyway. Okay, now in answer to your question, we're going to learn about climate change. Well, we'll talk a little bit about the idea of climate change, okay, and because obviously it's a thing. Earth's climate is always changing. You look throughout Earth's history, and there have been lots of periods of time where Earth's climate was very different, okay, than it is now, than it was at other times. Okay? I mean, there's about 500 million years worth of snowball Earth, okay, and other times where the Earth was like during the time of the dinosaurs, where it was far warmer than it is now. Okay, Earth's climate changes. There's lots of things that cause that. Okay, do humans have a part to play in that? Yes. Okay, would the Earth's climate change without us? Yes. Okay. Climate change is a thing, okay? It totally is. It's not a myth. I know there's people out there that say, ooh, climate change is a myth. Okay, you can say that, you can have that opinion, that's fine, okay? But climate change is a real thing, okay? It's a naturally occurring thing, okay? Can our activities have an effect on that? Most certainly they can, okay? Is it as doom and gloom and as big as everyone says? Well, that remains to be seen. We've only been able to study Earth's climate through, historical records for maybe the last couple of centuries, okay, and the rest of it is from ice cores and other types of data that involve a bit of extrapolation. Okay, so we don't know a lot about the Earth's climate. We do know that it has been different. Okay, we can prove that from the samples and research that's been done. Okay, but whether humans are totally to blame for what's going on, that's not for me to say. Okay. I can tell you that climate change is a thing, okay, but it has occurred naturally far before humans were even on this planet, okay? It was happening for billions of years already. Okay? All right, so what we're going to go over today, components of climate, okay, so we'll talk about what things make up climate, okay, we're going to look at the factors that affect climate, okay, we're going to look at the effect of climate on plants, animals, and humans, that's a pretty quick part, okay, look at energy inputs and outputs, and learn about climatograms, because tomorrow, okay, we're going to start an activity reading climate graphs, okay, analyzing climate graphs that we will do tomorrow and the first day back after Christmas break. Okay. All right. So if I was going to describe climate, let's say the climate of Okotoks, what things would I include in that description?
Sunny.
So amount of light. Okay. What's that? Okay, wind, yeah. What else? Yeah, precipitation. And temperature. There's your 4 parts of climate. Okay, the 4 components of climate are temperature, precipitation, light, and wind. Okay, basically the things you'd want to know right away when you open up the weather app on your phone and check what the weather is. Okay, those are the things you want to know. How hot is it going to be? Is it going to rain, snow, hail? All 4 in the same day, okay? We know how it is in Alberta, right? If you don't like the weather, wait 5 minutes, okay? And, obviously we would have to know if it's windy or not, okay? We're supposed to get some kind of Chinook today, okay? All that kind of stuff, okay? All right, so components of climate are, okay? Temperature, precipitation, light, and wind. Definitely need to know that, okay? In your notes package, that sentence is big, right? Now, the other thing that's big is the definition of climate. Okay? Climate is the prevailing weather conditions at a location, not to be confused with the averages. Okay? Because a lot of people, when they say, oh yeah, climate's the average temperature. Well, if I was to just use averages to describe the climate of Okotoks, this is what it would sound like. The average temperature in Okotoks is 6 degrees Celsius. the wind is typically from the southwest at 30 kilometers per hour. Okay? There is on average about 1 millimeter of precipitation per day. Okay? And there's 12 hours of light and 12 hours of darkness. Which would be the same no matter where I was on Earth. It would be 12 hours. Like, averages don't make any, does that give an accurate representation of what the climate is like in Okotoks? Not at all. Okay? So the prevailing weather conditions at a location is also got to factor in, especially for a place that's far from the equator, what time of the year it is. Okay? So if I'm describing the climate of Okotoks in the proper way, okay, I would say first off that the temperature fluctuates. Okay? It can be very warm, mid-20s to high 20s in the summer months. Okay? But it can be very cold, -20, okay, or even colder than that in the winter time. Okay? Also, the amount of sunlight received varies throughout the year because Okotoks is quite far north of the equator. Okay? And as a result, the effect of the Earth's tilt means that the light received changes throughout the year. Okay? Going from a maximum on the summer solstice of like 16.5 hours, okay, to a minimum of about 6.5 hours, okay, on the winter solstice. All right? Typically, winds come from the southwest in Okotoks, but they do get winds called Chinooks that can be much stronger than that and cause rapid changes in weather. Okay, that's a better description of the climate of Okotoks. Okay, I haven't just used average numbers. I've talked about what happens in Okotoks. If I was, describing the climate of Cairo, okay, in Egypt, it would sound a lot different. Okay, because they're close to the equator, the amount of daylight doesn't really change very much. Okay, because they're close to the equator, their temperature is quite high and doesn't change very much. Okay? They get very little precipitation because they're in this equatorial area where the winds actually blow moisture towards the ocean and away from the land, so that's a desert. Okay? Things like that. Does that sort of make sense? Okay. Now, what are we seeing here?
Cloud.
What kind of cloud?
Big one.
What do they call it?
Cumulonimbus.
Cumulonimbus cloud. Okay? See how many of you remember your grade 5 science. Okay?
No, I remember that.
Yeah, in the summertime, you basically see one almost every day. Yeah. Well, at least through June, July.
Nimbuses, which are like white.
Okay, is this an example of all 4 components of climate acting together in a certain way? Yeah. We get those often in the summer because the conditions here in the summer are fairly consistent. Okay? But in order to get a thunderstorm, you have to have just the right conditions.
When there was that massive thunderstorm overflows one time, I was in Calgary, and you could see the massive cumulonimbus cloud from Calgary.
Yeah.
Just reaching up in the sky.
Yeah, this summer I actually was out guiding a person on the river, and we could see the cloud build all morning. And I kept looking at. He was from Georgia, so he had no idea which way the weather would go. I'm like, I bet you by 1 o'clock we're going to be hiding under a tree. And he's like, why do you think that? I said, because that is to the southwest of us, and it's definitely going to move this way. And sure enough, the thing built up and got all puffy and white, and then all of a sudden moved over top. And there we were, hiding under a tree, getting pelted by hail. Okay, yeah. All right, so the conditions have to be just right. First off, this requires energy to form, because they're going to release a lot of it when they open up. Okay, so it's got to be pretty warm. You don't typically get a thunderstorm on a cool day. Okay, so you got to have a fair amount of energy. You also have to have a lot of moisture. Okay, it's got to be fairly humid. Okay, whether that moisture is evaporating directly off the ground and lakes and whatever, okay, in that area, or it's being brought in from elsewhere. There's got to be moisture to drive this. Okay, they typically don't form on a windy day either, because wind will disrupt their formation. Okay. So temperature, precipitation, light, wind. Okay, we've got those 4 components. Have to be a certain way for this to happen. Now, how do these build? Okay, well, throughout the day, as water is evaporating because of the high temperatures and high humidity, okay, the water vapor will move up. Okay, and as it moves up, what happens to the temperature? The higher up you go, the temperature gets colder. Okay, so as that water vapor moves up, it eventually gets to the dew point. okay, to the point where water will condense. Okay, so that water vapor condenses into small water droplets, which we see as clouds. Okay, those water droplets then, now that they're back into a liquid form, try to fall back down. Okay, the problem for those water droplets is they're trying to fall back down, but there's a lot of warm, moist air moving upwards, so they don't fall. They get pushed back up. So those water droplets will go through this cycle. Okay, they'll go up, and they'll go up with all that moist air. Okay, as that moist air goes higher, the moisture in it condenses. Okay, and now those little tiny water droplets get bigger. Okay, so the more times these water droplets go through the cycle, the bigger they get. So if we get a thunderstorm that just has rain in it, okay, most of the time the raindrops are pretty big. Okay, but if we get a more severe one, okay, rather than just heavy rain, okay, what can happen with those water droplets is they go through this cycle enough times that they get high enough that the water starts to freeze. Okay, now you get these tiny little hailstones. We've all had that, right? You get the tiny little pellet kind of sized hail or the pea-sized hail. Okay, so that starts to fall back down. If you've got an extreme case of warm, moist air going upwards, it will push the hailstone back up. Okay, with the moist air. What happens to all that moisture? It freezes onto the hailstone, making the hailstone bigger. Next time it hails, okay, go out and grab a hailstone after, not while they're falling. Okay? Yeah, and just while you grab a pot or put a helmet on. Yeah. Okay, and just break it with a hammer. Okay, and you'll be able to see it looks like an onion. Okay, it has layers and layers. You can tell how many times that hailstone has gone through the cycle through the cloud by how many layers inside the hailstone. The bigger the hailstone, the more times it goes through that. Okay, so if we're getting golf ball sized hail, those hailstones have gone through that cycle a lot of times.
Oh yeah, you golf play.
Okay? Now,
Run across the street.
what's the biggest hail you've ever seen?
Golf ball.
Yeah, usually golf ball, I mean, it's rare, but around here, it's probably a once a year kind of thing. We typically get some, golf ball sized hail. Okay, but you can get baseball sized, softball, yeah, grapefruit.
Basketball.
Okay, the largest hailstone ever recorded was ice cream hail. It had 4 liters of water in it when it melted. It actually went through the roof of someone's house.
So it was like a basket.
Okay,
Yeah.
yeah. So it was
Bet
kind
you
of
get hit by
freakish.
that stuff.
Okay, but in Wainwright, Alberta, back in 2003, okay, they had softball-sized hail. Okay, every car dealership in the town had its entire inventory written off. Like they were nothing but parts, brand new vehicles written off and stripped for parts because they were beyond repair. Okay, like all the windows broken, the hoods like caved in, it was brutal. And every house in the whole town had to have a new roof. Okay, all the shingles.
The
taken
roofers
off.
must have been
Oh
so
yeah,
happy.
roofing companies were driving into town with all their equipment going, hey, you need your roof fixed, we'll do it. Okay, because there was just so much demand for it. Okay, so that's pretty rare. I mean, it takes an extreme supercell to make A, a tornado, okay, and B, hail that big. All
I've
right?
seen tornadoes. Those are cool.
They're cool if they're a long way away.
Yeah, that's
When
why
they're close, trust me, they're not cool. Okay, and lightning. Okay, that's a discharge of a lot of energy. Would you agree?
Yeah.
Okay, so there's a lot of energy. Okay, that thermal energy that helped to build this whole thing gets discharged in a lot of different ways. Okay, lightning being one of them. Anyone ever seen a tree struck by lightning?
Yeah.
It just explodes.
Sometimes.
Okay, and the reason it explodes is because when the lightning hits it, it boils the sap instantly. Okay, and when that sap boils, it just blows the tree apart. Okay, and there was actually a video on the Weather Network the other day of a guy who just put some stuff in his car and he walked away from the car. Luckily, he walked away from the car because the next second the tree got struck by lightning and it exploded and a big branch crushed his car. Okay, like if he'd have still been standing there, he'd probably been killed. Okay, like, crazy. All right, so does everyone understand how that thunderstorm stuff works? Okay, that's an interaction. We've got to have the right set of climate components, okay, the right conditions for something like that to occur. All right, now, if we're thinking about what things might affect our climate, okay, what are some things that might affect our climate? Or climate in general, it doesn't have to be ours.
Pollution.
Yeah, the gases that we make.
Okay, no, I'm not thinking climate change. I'm thinking, like, anywhere on Earth, what are some things that might make your climate the way it is?
Pressure.
Yeah, centers of high and low pressure is definitely one.
Like how close you are to the equator?
Yeah, that's the biggest one. Okay, latitude is by far like, if I asked you on a test, hey, here's a city, name the factors that affect its climate, name latitude. Doesn't matter which city I give you, name latitude. Okay, latitude affects you because Earth's axis is tilted. Okay, and if you're close to the equator, the sun is directly overhead all the time. You get intense sunshine. The further away you get, the less intense that sunshine becomes. If you're close to the ocean, okay, or conversely, like we are, far from the ocean, that can affect your climate. Large amounts of water can store large amounts of energy. Okay, for example, Vancouver and Calgary have almost identical latitudes. Okay, but is the climate of Vancouver considerably more temperate than Calgary?
And rainy.
Yeah. Well, yeah, because it doesn't get cold, right? In Vancouver, if it snows, the whole city shuts down. Okay, they don't keep a lot of snowplows on hand there because they don't need to. Okay, it doesn't typically snow in large amounts there. Okay, because it rarely gets below zero because the ocean is right there, and the ocean would freeze if it got cold. Okay, the ocean stays there and it regulates the temperature because of the second law of thermodynamics. The ocean, okay, and the air above it have to stay around the same temperature because if the air gets cold, the energy will come out of the ocean to the air and keep it warm. That sort of makes sense? So being near the ocean is definitely a factor that affects your climate.
But it feels much colder because of the wind.
Well, but it's windy here.
Yeah, but no one's windy's there.
Oh, I beg to differ.
Ooh.
This is one of the windiest places in North America. Here to Lethbridge, yeah, it's super windy. Different kind of wind there. Okay, you get the sea breeze throughout the day.
Rain and.
Yeah, it's rainy there.
It's
Yeah.
always
But
great.
again, that's because you're close to the ocean. There's an input of moisture, right?
A sunny day in Vancouver.
Okay, what else? What's another thing that's different between Calgary and Vancouver? Altitude. Okay, the further up you go, the colder it gets. Okay, all right, this is good. You guys are brainstorming some good ones. Okay, latitude. Okay, single largest factor affecting climate. Single largest factor. Okay, your proximity to the equator drastically affects the amount and quality of solar radiation that you can receive. Thank you, Dr.
Is it more common for people around the equator to get skin cancer?
Um,
No, because they have
Not really. There are places that have higher incidences, like Australia actually has one of the highest incidences of skin cancer, but the ozone layer is also very thin there. Right? Like they talk about the holes in the ozone layer, one of those holes is like over Australia, so they have much higher incidence of it. And so, if we're looking at the Earth, okay, and the Earth is obviously tilted a little bit, okay, but if we're looking at the Earth, okay, from the perspective of intensity of solar radiation, when you're at the equator, the sun is directly overhead. Okay, so if we're talking about equal amounts of sunlight, okay, the sunlight that hits the Earth near the equator is concentrated in an area this big. But because the Earth is round, it's another thing flat earthers can't explain, okay, because the Earth is round, as you get further away from the equator, that amount of solar radiation is now spread out, same amount of solar radiation, but it's spread out over a larger area, which means now it's less intense, so temperatures get cooler. Okay, if we go even further north, okay, like look what it is up here where we are. Okay, same amount of solar radiation that hits at the equator, but it's covering almost twice the area. Okay, so it's obviously going to be colder the further away you go, north or south, from the equator. Okay, everyone all right with that?
It's actually because the Earth is flat and the sun's sitting overhead, so at the edges it's farther away.
Crazy talk. Okay, now, this is actually exacerbated by the fact that the Earth is tilted. Okay, so in the wintertime, when the Earth, and that's kind of what this is showing, this is actually showing the Earth tilted slightly this way, okay, sun being over here on the left, okay, because the Earth is tilted, in the wintertime, we tilt away from the sun, which actually makes that area even bigger. Okay, it also makes the days shorter. Okay, so if this is the Earth, okay, when the Earth is tilted away, the North Pole is over here. Okay, the sun can only hit the part of the earth that's facing it. All right? So the earth, because its axis is tilted, is actually spinning like this, spinning like this way. Okay? So how much time do we spend over here in the sun if the North Pole is tilted away from the sun?
Not much.
Not much. That's why right now, because today is the winter solstice, okay, the sun is going to make this pathetic little arc across the southern sky, okay? Because we're right here and we're looking towards the sun and we're tilted away from it. So it's making this tiny little arc that only lasts for about 6 hours today, okay, across the southern sky. But in the summertime,
So this is the shortest day we get.
yeah, this is the shortest day of the year, okay? In the summertime, the situation is reversed. Now we're tilted towards the sun. Does it make it more directly overhead? Okay, and if you're at the North Pole and the Earth's rotating around its axis, what does the sun do?
Something.
It never sets.
Yeah.
Okay? It's great to be a kid in the Arctic Circle in June. Your parents say, come home at sunset. You come home in August. Okay? And the sun does this. Like if you look up in the sky, if you're above the Arctic Circle, the sun does this. It goes around in a circle.
That's cool.
Okay? Because the Earth is spinning underneath it, and it can't set. Okay? I mean, for us, it's also trying to move in a circle, okay? But it's way further this way now, right? And so it spends way more time in the sky and is more directly overhead. Right now, right, it can only show itself for that much of the day. All right? So latitude affects the intensity and amount, okay, in terms of just hours of sunlight that you get. Okay? That's its effect on climate. So, on a unit exam, for Unit 4, here's how I'm going to ask about this. I'm going to show you a map of Canada, okay, and I'm going to pick a city, okay, and you're going to have to tell me what factors most affect its climate and what is the climate going to be like as a result. That's why we're doing this activity tomorrow and the day after Christmas holidays, because we're going to kind of look at a few Canadian cities. But if I ask you what factors affect climate, should you say latitude no matter which city I pick?
Yes.
Definitely. Latitude affects everything. It affects it differently depending on where you are. Okay, if I pick, well, I'm giving you a map of Canada, so I wouldn't pick Abu Dhabi. Okay, but if I did, right, you would say, well, the sun's going to be directly overhead all the time because it's near the equator. Okay, but we're going to pick a Canadian city, so you can say it's far from the equator, so the length of day and intensity of sunlight are going to vary greatly from summer to winter. All right, everybody all right with that?
Yeah.
Okay. Second factor, altitude. Why is there snow on the top of the mountains well into June most years?
Because it's colder.
Because it's colder up there. As you go up, the temperature goes down. On average, 6 degrees for every vertical kilometer.
Ooh.
Okay, so here, our altitude here in Okotoks is 1,100, actually in this school, it's 1,096 meters. Okay, above sea level. That means we are more than 1 vertical kilometer higher than Vancouver. Okay? Can that affect our temperature?
I assume
By
so.
about 6 degrees, yeah. Okay, I mean, that's not the only factor. Vancouver's also by the ocean. And that's why Vancouver's climate is considerably different from ours. Okay, but it's also a much lower altitude. Okay, if you look at other places at the same latitude, okay, that are lower in altitude, they're typically going to have warmer temperatures. Okay? All right. So you can kind of see that with this picture here. I took this picture before you were born. Oh, that's sad. Okay, so this was a backpacking trip that I did, okay, and we started out at this campsite that was at about 1,400 meters, so that would be like down here somewhere, okay? And when we left the campground, it was 16 degrees and it was raining, okay? We got up into this pass, okay, and we were at about, say about 2,000, 2,100 meters, okay, something like that in this pass, and it was starting to snow. Okay, we hadn't even gone up a vertical kilometer, but the temperature had dropped to the point where it was starting to snow a little bit. Now, that snow was coming from clouds that were obviously much higher than we were. Okay, it was kind of a wet, melty kind of, wet snow kind of thing. Okay, but that mountain up there, that's Mount Robson. That is the highest peak in the Canadian Rockies. Okay, it is like 3,000 meters, a little bit more than that at its peak. Okay, it was -20 blizzard whiteout conditions at the top of that mountain. Okay, that same day. So as you go up in altitude, okay, the temperature is going to go down. Right, Mount Robson has a glacier. It's got snow on its top all the time. Okay.
That's cool.
All right.
Where is that?
That is, so you know where Jasper is?
Yeah.
Go west of Jasper and you go from Jasper National Park to Mount Robson Park. And you can hike up to it. It's a couple days to get
What's
to it.
the tallest mountain in Canada? Yeah.
Mount Robson.
Oh.
Mount McKinley is the tallest in the Rockies, but it's in Alaska. Okay. Okay, so another one, I think Corey, you mentioned this one, that how close to the ocean you are. Okay, because land gains and loses heat faster than water, and this has to do with specific heat capacity, which we haven't talked about yet. Okay, being close to the ocean can regulate your temperature. Okay, because the ocean's temperature is not going to change drastically throughout the day. Okay, if you're in Canada, okay, you approach the ocean in a certain way, like this. Right? All Canadians approach the ocean like it's going to be cold because it is. Okay? You can always tell the Canadians when you go to a tropical place. They're always the ones who approach the water with trepidation, okay? Because their experience is water is always cold. Okay? When in fact down there it will be nice and warm. All right? So you got the distribution of land and sea. If you're close to the ocean, typically it can have a regulating effect on your climate. And we see that on the west coast of Canada. But we actually see a different effect on the east coast of Canada because of the next thing, the nature of ocean currents. Okay? The ocean has got parts of it that move, okay, because of different types of currents. Okay? On the west coast of Canada, we have the California current going by, okay, and you also have the Alaskan current, which is part of the North Pacific current here. So we typically have like warmer water on the west coast. And by warmer, I mean like it's, a couple of degrees warmer, right? But if you go to the east coast of Canada, okay, you've got the Gulf Stream coming up. The Gulf Stream is actually starting to move further north. This here is Newfoundland, okay? Now, Newfoundland, you can see, is affected by the Labrador current, which comes straight out of the Arctic Ocean, right? How cold is that water going to be? Very cold. This is why hurricanes die typically right here. Okay? Hurricanes are built and they grow down here in the Gulf Stream, okay, where you've got equatorial currents, warm water, okay, and they always follow the same path. That's why I don't understand why anyone wants to live in Florida. Okay? So the hurricanes will build and then they always do this. They follow this, okay, and then they die right about here because the water gets too cold to keep supplying them with energy and they just peter out. Okay? Or they make landfall, and once they get onto the land, there's not enough moisture to keep them going. Okay? So it's typically how they work. So you very rarely get any hurricane-type storms in Canada. Lately, we've been getting a few more. Just things are changing. Okay. Okay. So does that make sense? Okay. Depending on where you are, you get different types of currents. Okay. You can kind of see on this map which ones are the warm water currents and which ones are the cold water currents. Okay, and that makes a big difference for your climate. Okay, that's why the east coast of Canada is considerably colder than the west coast. Okay, like winter in Newfoundland is brutal. Okay, I mean it's not temperature-wise a whole lot colder than our coldest days, but because they're right next to the ocean, the humidity is higher, and a wet cold is piercing.
To your bone.
It goes right to your bones. Yeah. Okay. We have a very dry cold here, right? Wet cold, man, it's brutal. And when they get snow days.
Also, they don't have snowstorms; they have ice storms, where like a foot of ice will be stuck on your car. And you have to use a pick to get it off bit by bit.
But they also get big snowstorms. Like my wife's from Newfoundland, and like I remember her telling me because I opened up their closet when we were visiting, and there was a snow shovel in the front closet. I'm like, why is there a shovel in the closet? And they're like, because in the wintertime, you need it inside the house. If it's outside the house, you can't get out of the house. Okay? Because when they get a big snowstorm, it's higher than the door. You open the door and it's like, oh, I'm not going to work today. Okay? Because the door is blocked by snow.
When we went on our grade 9 trip to Quebec,
Mhm.
it was in the middle of February, and it was so humid on the first 2 days and so cold that like it was -40, and then with wind chills, it was windy too,
Mhm.
and we were all like freezing the entire time because it was like wet, humid, and we were all used to the dry.
Yeah, it's a very different type of cold, the wet cold. Yeah, very, very different. And it, of course, leads to higher precipitation, right? Like, around here, we're like, oh, we get snow in the wintertime. The amount of snow we get doesn't amount to a lot of moisture, okay? So just so you guys know, to get the rainwater equivalent of 1 centimeter of rain requires 10 centimeters of snow. Okay, so if you have 10 centimeters of snow and you melt that, it's the water equivalent of 1 centimeter of rain.
Okay, Josh.
Okay, and then of course we've got some ocean currents that are present only periodically, like El Nino and La Nina. Right now, we're in an El Nino series, okay, where the warm water off the coast of Chile, okay, the country, not the food, okay, so it's causing this warm water to rise right here, okay, and that actually can affect global temperatures, even though, because it will actually raise the ocean temperature by a couple of degrees. Okay, now if you think about that, I know a couple of degrees doesn't seem like much, but when you're talking about the amount of water, it's a huge amount of energy. Okay, so there's those currents. When we get the La Nina, that's when we get the long, brutal, cold, snowy winters. Okay. All right, and then distribution of mountain barriers. Would this be one that affects us? Okay, so in this picture right here, okay, we're seeing what's called a rain shadow. Okay, you see on this side of, so here's the mountains here, you can see the white tops. Okay, on this side of the mountains, everything's green. Okay, but on this side of the mountains, it's a desert.
Yeah.
Okay, the same thing is here. Okay, we live in the rain shadow of the Rockies. Okay, in BC, big forests, tons of trees. Okay, Vancouver, very wet, almost a temperate rainforest in some parts of BC. Okay, but you go across the Rockies, and on the other side, okay, is grassland, prairie, semi-desert, like what we live in. Okay, because the moisture doesn't make it over the mountains. Okay, so we've got moisture coming in from the Pacific, but it gets pushed up. Okay, it has to go over the mountains. And as it tries to go up and over, the temperature drops and the moisture condenses and falls on what we call the windward side of the mountains. Okay? On this side of the mountains, which is called the leeward side of the mountains, it's going to be dry. This is also what leads to Chinooks. Okay? So you ever notice that when we're going to get a Chinook, actually you can see it right now, okay, the arch, okay, we get that arch, okay, the reason that that happens is because air comes down off the mountains, it's cold and dry as it goes over the top, but gravity pulls it down and accelerates it down the mountains. Okay, so it builds up, and it builds up not only speed but also pressure. Okay, and so there's a massive pressure difference, okay, right against each other. That's what forms that Chinook arch. It's all this high pressure that can't hold any moisture, and a lower pressure area on the other side that can. So you get that cloud bank that has a very sharp arch-shaped border to it. Okay, and that's why we know when we see that, we're about to get a Chinook. Okay, because we know the pressure is building up there, and it's going to start bringing air from a high pressure area to a low pressure area. Everything wants to go from high to low, okay, and it's going to start to blow, and we're going to get that warm air. Because as that air comes down the mountains, okay, there's kind of a friction, or what they call a katabatic heating, okay, that goes on. So it scrapes and rubs against the mountains, okay, and warms up as it comes down, okay, making it warm and dry, and it'll actually draw moisture out of the ground, okay, as it blows across. That's why it melts all the moisture, okay, and why it's typically very dry on this side. Okay. All right, so that sort of makes sense? So if I asked you to describe the climate of Okotoks, would this be one of the factors you would use?
Yeah.
Definitely. Okay, like second basically to latitude would be presence of mountain barriers for us. Okay, could you use mountain barriers if I asked you about Vancouver? Actually, you could, because they're on the windward side. Having the mountains right there is what gives them all their precipitation. So you could say that they're just the other side of it. Okay. Now, if I asked you about Manitoba, like let's say Winnipeg, probably not. Okay. All right. Okay, and then patterns of prevailing winds. Okay, here typically our winds come from the southwest, so they typically bring us fairly consistent weather. Okay, but if we get something coming out of the north, do we know something bad is coming? Yeah, weather-wise, nothing good comes from that direction. Okay, if we get a northeast wind, we know we're in for it. Okay, and in the wintertime, a northeast wind, okay, meeting up with some moisture coming from the south usually leads to something really bad. Okay, and when you've got this high pressure area right here, okay, and this low pressure area right here, okay, they typically interact like this. So the circulation goes this way and this way, okay, and when they meet, their effect goes right here, right down Highway 2. Okay, so typically that's why Highway 2 is such a nightmare. Okay, whenever we get a storm, all the big hailstorms, thunderstorms in the summertime go along there. Okay, in the wintertime, that's where the worst weather goes. It's just because of those centers of high and low pressure and where they're located. Okay, and then obviously our prevailing winds. All right, I think that's all I needed to cover, and we got it all done. So we'll talk about climatograms tomorrow and start our activity tomorrow. Okay, and then we'll finish it up on Monday after